In this example, we want to find the limit as x approaches 4 of the rational expression. To do that, we're going to need to type this in the calculator. We're going to use the graph and also the table then to help us figure this out. So if you go to y equals, you're going to want to use a left parenthesis first. You need to group everything in the numerator of the rational expression together. And then also you need to group everything in the denominator of the rational expression together. So you'll type it in just like this. I'm going to do a double check just to make sure I've got it right, because anything after this, if you don't have the equation in or the expression in right, you are not going to get the right answer. So it looks like everything is as it should be. If you need an extra minute or a few seconds to type this in, just pause the video. Then what we'll do is we'll check out the graph. I'm going to hit zoom 6, a nice standard viewing window to start with. And then we're going to see what happens if we try to get closer and closer to an x value of 4. So I'm going to zoom in a little bit here. So I'll go to zoom, and then number 2 is zoom in. And I'm actually going to cursor to the right just a little bit. And the reason why I'm doing that is I really don't care what's happening with the rest of the graph. I only care what's happening right around x is equal to 4, excuse me, x is approaching 4 for our limit work here. So I'm just going to put my cursor right there and zoom in on that part of the graph. I can now hit trace, and then if I trace to the left and to the right of 4, I can see maybe the value, the y value that we're bouncing around. So here I'm to the left of 4, and my y value is a little bit bigger than 1.5. And then I'm really close to 4 right now, an x value of 4, and my y value gets even closer to 1.5. If I go to the right of x is equal to 4, like about 4.28 here, my y value is a little below 1.5 or 1.5. And as I get closer and closer and closer to an x value of 4 from the right, it looks like my y values are approaching or getting close to 1.5. Let's use the table to see if that's actually the case. So we're going to go to second window, which is your table set. This time my table start does not need to be at 0. It needs to be at 4, actually. Whenever you're finding a limit as x approaches a particular number, you want that table to start at that number because we want to stay real close to that x value, and we don't want our table to be delta table to be 1. That'll march us further and further away from 4. We want to stick real tight, real close to 4. So we're going to make our delta table, which is how the x's will change, pretty small. Then I'm going to go to the second graph, which is the table, and we can see here, if we look from the left and the right, there's like a missing number here, or what we're approaching from the left and the right is the same thing, and that's 1.5. So we should be pretty confident here that the answer to this limit question is 1.5. The reason why there's an error when x is exactly equal to 4 is because the function is undefined when x is 4. 4 squared minus 4 times 4 makes the denominator 0. So that's why there's an error there, but the limit still exists.